things we will take to the tool flow, and each step of the full custom, and you can understand, how to uh, within the recording has started. Who has done this? Click the recording. Okay, so we will start the tool flow. I hope Sujit will has access. So Sujit will demonstrate that he's a research scholar, PhD student, and in associate lab he will present the flow very briefly, and you have to follow the each step, and I will give the assignment, and I again have to redo the same flow, and you have to submit as an assignment to me, and I will take the test in the later stage. And at the end of the semester, or after the mid semester, after a couple of classes, I will do the testing, and finally we will take a quiz and everything related to the software part and tool flow. Okay, so Sujit, take over and share the screen of your. Go from the very scratch. How to access the
Okay.
tool also. Starting
Okay,
just
sir. Okay, sir.
go to the X manager, or starting how to do the CSRC, how to get the license, everything. You just speak from very beginning so that they can do through the VPN.
Okay.
Okay.
Okay, sir. Okay, sir.
Uh-huh.
So my screen is visible to everyone. Hello.
Sir, it is visible, visible.
Okay. Okay. So the first step to invoke the tool. So the tool is installed on the server. So for which we are going to access through the command window. So we have to start here Excel manager. After that, you need to have one user ID which will use to access your tool. So here we first put or your our user ID to reach the server where the cadence is installed. So first type the command means in which SSH and your user ID. Let's say if my user ID is Sujit, so I have written the my user ID here SUJEET, and after that we have to provide the IP address of the server. So at the rate of 172.16.24.155 where the cadence license is installed currently. So we have to reach to this server by getting our user ID and password. After clicking this, the tool wants the password for the user ID. So you have to put your password. So I have written the password here and click to the OK. Now we do reach to the smdp underscore server 1 where cadence license is installed. The first command is to go to the address where the cadence is installed or where the chrc file is installed. So first either you go to that particular folder or you invoke into the C cell license. So first either you write csh, invoke the C cell, and after that you have to change to the working library directory where the chrc file is available to you. So we have to write cd change directory cadence underscore ms underscore labs underscore 614. So go there, and here our chrc file is available in which the all the address of tools and license is available. So first invoke the chrc file. So for that you have to write source source. After that chrc file cshRC, enter. So the message is welcome to the cadence tool, and for the virtuoso invoking you have to write the command virtuoso, and so after entering this command you will enter into the tool. So till now any doubt or any confusion? So these two or three commands for invoking the tool, and
So
you
just
have to.
you keep on going, continue on. Here
Okay,
it is
okay,
recording going on, they can go through it. Okay.
okay, sir. Okay. So our tool is invoked. So the first step is to you have to create one library. So for which you have to go to the file option here. So here click on the file option, and you have to create one working library in which you are going to design any schematic or design. So here go to the new, and you have to create one new library first. So clicking on the library, you can name any library of your. So let's say it is a demo library. Here I am going to create a demo library. So I have named it demo. So in the technology options, you have to attach the third option. You have to choose attach to an existing technology library. Means this library is going to attach to the existing library. So choose this third one option, then click on OK. So these are the available library which is already available in the cadence. So you have to choose in which library you are going to attach from your custom library. So right now we are going to the GPDK generic purpose 180 nanometer library. So click on this GPDK 180 nanometer technology and click on to OK. So it will add the GPTK 180 nanometer library to your library. Next step is, this is the step of your custom library creation. Now you are going to work on your own library in which 180 nanometer is already attached. So for that you have to go to the cell view generation. So in this also you have to go to the file option. After that you have to create one cell view, because you have already created one library. So you are going to create cell view under the your custom library. So first library you have to choose. So I have created one demo library just before that. So choose the demo library and name the cell view. So let's say we are going to design a inverter. So you have to write the name of the cell view. So I have writing in inverter underscore demo. So this is the cell name, and which is the view type. We are going to create a schematic view. So from here you have to choose which worksheet you are going to create. So I am going to create one schematic window. So click on OK. So it is taking time. So there is a license. So retry to access the license. So the workspace is created for you, and this is the schematic virtuoso. Here virtuoso schematic editor is open for you. Now you are going to create any type of circuit using CMOS technology. So we are going to demonstrate a CMOS inverter, so for which one NMOS and one PMOS is required. So first we have to choose a NMOS and PMOS. So for this you have to initiate the NMOS and PMOS, for which a shortcut is either you press I from your keyboard, then add instance drop down window is open, and you have to browse from the library section. As your technology library is GPDK 180, so go to the GPDK 180 library and you have to choose the cell. Means I am going to choose first NMOS. So here NMOS is given here, and you have to choose which type of view. So I want symbol view. So here symbol. Now close. So this is the NMOS view type is symbol, and these length and widths are given to you. So according to your requirement you can change these. Means you cannot go beyond 180 nanometer, but according to your requirement you can change the length and width. So hide here, and this is the NMOS. So we want one NMOS which is the here, and similarly we want one PMOS also. So here we are going to choose the PMOS symbol, hide, escape. So we are getting one CMOS and for CMOS, one NMOS and one PMOS. So this is the NMOS and this is the PMOS. So we have to make the connection for completing one inverter. So for that we required a wire. So from keyboard you choose W key to select wire, or you can directly select from this window here. So W
Sir,
for wire. Yes.
so can you zoom in if possible? It's very small.
Okay, the window. Let me. Now it is visible.
Yes, sir.
Okay. So the for selecting the wire, either you can choose from here, or you can press W keyword from the keyboard. So it is selected. So click first where you want to connect, and after that you have to. So likewise you are going to connect all the terminals. So this is gate of the PMOS and this is the gate of NMOS. And this is the drain, and this is the drain of PMOS, and this is the drain of NMOS. This is the source of NMOS and this is the source of this is the source of PMOS and this is the source of NMOS. This is the body of NMOS and this is the body of PMOS. So if you know the configuration of inverter, then you can wire these two uh, transistor accordingly. So body of the PMOS is going to connect with VDD or directly drain, the source, and the body of the NMOS is going to connect to the source of NMOS or directly ground. So after that we require some input output ports. So for this either you can choose by this here, or you can press P from your keyboard. So it will going to create the pins. So we require one input pin and you can name it accordingly. So I going to name it IN, and here place here, and after that I am going to connect this input to this gate. After that I require a output pin, so here, and name it like out. So connect this wire from this to this. After we require two supply, one is ground and one is VDD. So you can choose either direct, you are going to either use direct supply or you can use a in-out port here. By both the method you can do. So we are going to choose in-out port here. For VDD, we write it VDD, and for ground, GND. So for wire, connect this. So here check and save. So this circuit is clean. So there is no warning here. Till now, any doubt? So this is the wired connection of a CMOS inverter. So how we are going to connect from PMOS to NMOS. This is the wire connection of NMOS to PMOS in a CMOS inverter. That's all. And these four pins, one pin is input, other is output, two pins are for supply, VDD and ground. So after that we are going to create one symbol for this inverter. So for this, you have to choose the create option here. From this create option, go to the and try to create a cell view from cell view. So we are going to create a symbol for this schematic. So go to the option create and create from cell view. So option is here in the library demo. Cell name is inverter underscore demo. From the views schematic to the view symbol. Click on OK. So these are the options which is provided by the tool. So input in is the input pin which is to the left of your circuit. Out is output pin which is provided to the right of. Top pin we want to VDD and ground is we want at the bottom. So we can place ground here. So it will create a symbol of inverter here. So now we can create any shape of the symbol. So we are going to delete first these lines and now we are going to create a symbols. For that we are going to here choose the option of create first shape, selecting the line and drawing the inverter like structure. So this is the arrow. After that we require one bubble or circle. So create, go to the shape and this circle and clicking on here. Okay, now we are going to place this. So just drag and drop. First select all these options, then drag and so after this you have to check and save option. So this is not giving any warning. So our symbol is created here. So now after that we are going to close this. In the library we can also see in this, if you are going to library manager and you have created one library name as demo. So also you can say we have using one cell view inverter underscore demo and we have created one schematic and one symbol. So if you going to open this, so the symbol is going to open so that you can use anywhere. So now after that we are going to enter into the simulation of this inverter section. So the designing part is complete. So we are going to use the simulation edit simulator, spectre simulator. So launch, go to the option launch.
ये सुजीत,
Yes sir.
एस्पेक्ट रेशियो बताया PMOS NMOS का?
नहीं सर, नहीं बताया सर.
अब बता दो कितना
ओके सर.
WL रेशियो विथ कितना लिया?
बाय डिफॉल्ट है 2 माइक्रोमीटर.
नहीं उसको भी कर देना, नहीं तो फिर
अच्छा ओके.
So मैं बताता हूँ, ठीक है? ये see aspect ratio of the aspect ratio means W/L ratio of PMOS to the aspect ratio of the NMOS should be 2 to 3 times. Okay, because this is because of this is the reason because of the mobility, right? So since the mobility of the NMOS is NMOS not the electron, right? The electron is 2 to 3 times your holes, that is the PMOS. So that's why aspect ratio. If you look at the same drain current flow, if you look at ID1, IDP equal to IDN, then we will have a mu n by mu p by mu n, then that will be your WP by LP and by WN by LN. That should be 2 to 3 times. So you have to maintain the 2 to 3 times aspect ratio of the PMOS, that is WL ratio to your NMOS. So if you fix the L equal to 180 nanometer, 180 nanometer, that is equal to the minimum channel length or minimum feature size. Okay, then W has to be twice or 2 to 3 times of your NMOS. So if you W fix micron of the NMOS, then PMOS you have to maintain at least 4 to 6, right? 4 to 6. So you keep around 5 micron the PMOS. Change the PMOS, okay?
Okay, sir. Okay. So the NMOS width.
Go to the property and change. Otherwise, change the W also, W of the NMOS also.
Okay, sir. Okay.
Put 5.
Okay, sir.
W.
So here we are going to change the property of a PMOS. So for that, either you
पहले
select
पहले
from the
NMOS क्या कर देना? पहले NMOS क्या कर देना?
कितना करना चाहिए सर?
NMOS का 4-5 कर दो, जितना भी हो 4-5 कर दो.
ओके सर.
तो दैट डिफरेंस है, 2 भी रहेगा तो चलेगा चलेगा, कोई प्रॉब्लम नहीं.
ओके सर.
2
So here we are.
NMOS का चेंज कर दो 5.
Okay, sir. So the width of the NMOS is 2 micrometer. So here we are going to change the width of PMOS according to the aspect ratio. Let's say we are having multiple of 2.5. So we are going to change the width of this PMOS here. So we have to write here 5. So 5 is, and here apply. So the width of NMOS is changed here 5 micrometer. So according to the requirement, we can change the width or length of the PMOS and to satisfy the aspect ratio. So now we are going to enter into the simulation mode. So we are going to launch the simulation ADL window here. So for this, click on the ADL. So it will enter into the simulation window. So now we are going to give the input of all pins. So we are not using any source directly. So we are going to set up the ports and give the port direct input. So here setup and go to the stimuli so that we can give the input directly. So for ground we require a DC pulse of 0, DC voltage of 0 volt. So enable this function DC value 0 and then apply. So ground pin is set to 0 volt. After that we require to give the value to the VDD. So go to the select here VDD, enable function DC value. For 180 nanometer we have to provide 1.8 volt. So here we have to write 1.8 and apply. So this VDD is set to at 1.8 DC voltage. Now we are going to give input to this input pin. So select this input pin here, and we are going to check the means the transient simulation. So we are going to use the pulse. So enable here, and function type we are going to select pulse. So voltage 1 is either 1.8 or 0, you can choose. So we have chosen first voltage as 1.8 volt and second voltage is 0. Let's say we are going to give a period of 50 nanosecond. So the width is half of this 15 nanosecond, 25, and you can choose rise time fall time, give the rise time fall time, but it is not necessary. So
You
can
I will tell you, you have to play with the different rise time and fall time, and you can check your characteristics. Okay, so at least
yes.
You keep 0 0 here at
Okay,
Sujit,
sir. Okay, sir. Okay, sir.
or
0.
some 0.001 kind of stuff you can give.
Okay, let's say I am going to give 1 nanosecond.
Now 1 second is high, right?
Okay, sir. So 0.
Oh, okay. What is the written?
0.
Oh,
0.
0 0 0 1 no, no,
0.
Pico में आएगा.
0 1. Okay sir, nano.
No, हाँ.
And fall time also
Same.
0.001 nano. So after that we are going to apply this. So all our input are set. So click on OK. Now we are going to choose which analysis we are going to perform. So in this window we are going to choose the analysis type. So let's say we are going to perform transient analysis. So as our pulse width is means the pulse period is 50 nanoseconds, so we can give here.
But you have not selected source voltage, na? Yeah, Sujit.
Yes, sir.
So source voltage you have like for input voltage source, where you have selected?
Sir, for the VDD we have selected in this also. Means here stimuli source voltage VDD. VDD is 1.8 volt directly.
But it is not showing in the window.
Yes, because it is already embedded in this. As input is also not showing. Okay, so we are going to choose the transient type. So we are going to transient analysis. Stop time we can choose according to our requirement. So let's say 1 micrometer, 1 microsecond, and this accuracy type of default, and apply here. Okay, now we are going to choose which waveform we require. So from this window here, choose at which node we require which waveform from design. So let's say we require VDD as we given ground.
No, why VDD ground?
For checking as we given the 1 point. Okay. So only we can deselect here. So we can deselect. Okay, sir. We can deselect from here. So first we require output. After that we require input.
Not selected input.
These two are so we can choose. Okay. And this.
Is selected. Input is selected.
Yes, sir. Yes. Here. So we are not going to plot this VDD and grout. So we can directly delete it also from this option. So our outputs are out and input. So the simulation setup is complete. Now we are going to simulate this. So if you want to save the output, so click on this save data for the further use. So
and
here
don't save.
Okay. So here we are going to run this. So this is the this is the output wave we are going to receive. So these are spikes coming due to we have chosen the higher value of width and length. That's why these are coming. So if
this is because the rise and fall time up,
Yes, sir. Rise and fall.
So if you change the rise and fall time, you see that spikes are will be filter 1, and also it can be filtered by changing your aspect ratio also. So two aspects you have to look at. One is a aspect ratio, and also your input rise time and fall time, which will affect your these spikes in the edges. Okay, so just continue.
Okay. So let's see. Or I am going to proceed for the layout design. Or going to.
Once it is done, then go to the layout design. Okay.
So it is already done, sir, because we are already having the transient analysis.
But tangent analysis is done. Na? Characteristics you will take later. Okay. And the other DC characteristics, I have not taught to them. Okay, sir. Today, this week I will complete it, and maybe next class they will go to further DC analysis. Okay. Tangent analysis I have done already. So Now after simulation, we can go to the directly layout design.
Yes, sir. So I proceed for the layout.
Yes, you go proceed for
Okay,
that.
okay, okay. So the transient analysis is done
Hello.
and the pre-layout. Hello.
Ah,
Sir,
do you have any doubts till this point? Akanksha?
sir, for this Nilfas this side, sir. Sir,
Nilpa?
this spike, yes, sir.
Ah,
Sir, this spike is coming due to charging and discharging of capacitance of this MOSFET.
yes,
Isn't it?
because of the different aspect ratio. One, that is aspect ratio will affect your, that decide your resistance and capacitor in the path. So one. Second is that rise time input rise and fall time. Okay. So if you have a sharp rise and fall time, there is a chance of the spike. So that affects both rise and fall time of your input vector and also your aspect ratio of your devices.
Yes, sir. Yes, sir. So the spikes is gone up to the 2.4 volts. So let's see if we are going to change the aspect ratio. So just wait. I am
You
going to
can change,
change.
हाँ change it, you will get it also. बढ़ा दो थोड़ा सा दोनों एल एल को भी.
Not selecting. So if we are going to change this, or we can decrease this to 2. Let's suppose 2. So the now we are going to simulate. We already saved this. We are going to simulate. So it will also come around this. Okay, 2.4 not. And after that we are going to change the rise time or fall time. So go to setup. So if we are going to change this rise time and fall time, so it is not changing, but we have to choose the specific value of W and L for the this. Or we can change here also frequency. So it will decreasing, but we have to choose the specific amount of W by LS to minimize these spikes. So now we are going to enter into the post layout, means the layout of this circuit. So first close all the simulation window here. So our simulation window has been closed. So now we are going to create the layout of this CMOS inverter. So we have to go to the layout window editor. So from this left side top corner, we have to launch the layout editor. So we are going to choose the layout Excel here. In this, we have to choose create new, and configuration is automatic. So click on OK. So you have to check whether your library is correct or not. So we have created one demo library in which we have created one inverter underscore demo cell, and we are going to create a layout. So the view type is of layout is correct. So now we are going to choose OK. So we have entered into the layout window. Any question till now? So now we can, in this window, we can import the layout schematic to this window.
See, Sujit.
Yes, sir.
Just a minute. Let me tell to them
Okay.
regarding this palette actually. Okay.
Okay, sir.
See, if you look at the left side of your window, this layout window, that is virtuoso layout suite Excel. Left side, if you look at, there is a palettes, layer palettes, which is given for various layers like NOL, PUL, then oxide layer. Then if you look at the metal layers, metal 1, metal 2, metal 3, similar via 1, via 2, via 3. Okay, and if you look at the go down, diffusion layer थोड़ा देखा देना. So it has a metal 6 diffusion, एक diffusion देखा देना. नीचे होगा ना? नहीं है diffusion का. Perly layer is there, right? No, annual fuel, that is annual fuel, right? Diffusion
Yes, sir. Annual and POL.
हाँ, but diffusion का
Active.
active कहाँ है?
Sir, it is of from different name. I guess it is of these are the layers. These two are the.
ये है ना ये वाला
One
नहीं तो
second, sir.
नहीं उसको तो बड़ा बड़ा करो तो वाइट करो तो हाँ ये होगा. ये तो पॉली टाइप का लग रहा है.
नहीं पॉली है सर. ये एक्चुअली जेनरिक है. इसमें सब चेंज है. नेमिंग एंड
वो जेनरिक का है ना ये.
यस सर. ये जेनरिक है. इसमें सब चेंज है.
हाँ ठीक है, बट एन सिलेक्ट लेयर इफ यू हैव एन सिलेक्ट annual poly name
Annual PWell and
हाँ
oxide layer is this. The poly layer is this. These are the active layers, I guess. These.
no, poly is the okay for the poly layer.
GCC in the poly in generic poly is GCC on the SCL. SCL side it is named as GCC. Means the
I think
GC
that's,
layer.
and just to make the cursor NEMP, just to put the cursor at the NEMP. NEMP or PMP? No, NEMP PMP में हाँ just ना NEMP just पल्ली के नीचे जो है ना
Yes, sir.
क्या दिखा रहे हैं प्रोफिलम जिधर?
Draw. These are the layer.
Okay. No, I'm asking no how to get your diffusion layer. So that's what active layer.
These are the, sir.
These are the active layer, PMP and NAP.
Yes, sir. Yes, sir.
Okay. Okay, continue. So what I mean to say, now these are the layer palettes, layer encoding. You can just select it and draw your layers depending upon the aspect ratio and according to design rules, what is the spacing between two layers. So that spacing, alignment, and minimum size, that is resolution. According to the design rules, you have to select it. And have you talked about this micron based design or lambda based design? Have you set it, that one, Sujit?
No, sir. No, sir.
You set it that fast, no? Then
Actually,
grid you have to set it, right?
yes, sir. Yes, sir. Yes, sir.
You set it at either micron or lambda.
Okay, sir. In this. So this is the set by the grid type of, and we are going to choose the spacing between these two lines. So the snap sizing is by default 0.005 for x direction, and for y direction 0. So this is the working space, and these are the property of your working space. So now we have to import the schematics, this cell used in this schematic, to this layout window editor. So for which we are going to create here connective into the connectivity option. We are going to generate all from sources. So we have to embed all the schematic cells to this layout window. So all from sources. So generate instance IO pins, CR boundary, IO pins. These are we are also going to choose the labels. So layer them as layer purpose same as label, or same as pin. We can choose OK. Click on OK. So now our layout is here. So PMOS cell and NMOS cell have their layout model in the library already given. So for this, you can press Shift F so that it can access the original layers of the PMOS and NMOS. So now we have to connect all these layers to layers and design one layout here. So this is the PMOS and this is NMOS. So according to the our schematic, we have to connect. So in this is the poly layer or gate. You can, this is the drain or source, and drain or source can be interchangeable, so you can use any drain as a drain or source. Similarly for the NMOS also. So now first we are going to connect gate of PMOS to gate of NMOS.
Alignment
So
कर दो
this,
ना सुजीत, alignment कर दो पहले.
okay sir.
शिफ्ट करा दो,
So
मूव
we
करा
have,
दो माउस को,
okay
लेफ्ट को. नो नो, करेक्ट. नो, ज्यादा हो गया, ज्यादा और लेफ्ट लेफ्ट. हाँ शायद और थोड़ा सा हो जाना चाहिए.
so now we are going to connect for this layer. So this is the poly layer of gate. So we have to choose poly layer from this layer palette. So this poly option is given, and so for that we are going to click on the flow poly, and you have to create which shape. So we are going to choose rectangle shape. So either choose from here, or you can directly press R as a shortcut. So we have chosen to create a rectangular shape. So click on this, one click, and it will going to create a one rectangular window. Now from this poly to this poly we are going to connect. So this is created. Now we have to perfectly match this poly to this poly. So here mismatch is there, so we have to move this. So for move, first select the cell and press on keyboard M, and match. So one side is match, and this is the not matching means the poly layer which we have created is of higher width. So we have to reduce the width of our poly layer created here. So for that we are going to snap this layer created. So for that a shortcut is S. So we are going to press S and select this layer. So now it is not selected. Escape. Press S. Yes, it is lock, so I have to enter. Yes. So let me just complete the design. After that, the DRC error can come and we can resolve one by one. So the idea is first this should be properly aligned. Otherwise, it will give you the design rule error. So
You just do it, and automatically once the DRC will come, automatically will change that time. Okay. You
okay, sir.
continue.
Okay, sir.
Don't make perfect
Okay,
now. Huh?
okay, sir.
People
Okay.
should
So now
understand also mistakes.
okay, sir. So now we are going to connect this to from this to this. So we require a metal. So now we are going to change select the metal, and it is of metal type 1. From color you can understand. So we are going to choose metal 1 here and press R to create a rectangle. So so these two are supposing that these and this is drain. So we have connected drain to drain, and similarly the both the drain connection is going to connect to the output here. So we are going to connect it to the output. Now input is given to the gate. So we require gate as an input. So first we are expanding this poly layer, and we have to connect this metal to this poly layer. So we required a via. So choose here create and select the via here and choose the option Via definition, metal 1 to poly 1, this option. So hide. Now the connection between metal and this poly is established. So we are going to connect this input port to this. So we have to select a metal layer. So connection has been made.
Just Sujit,
Yes sir. Yes sir.
just go, हाँ zoom करके, हाँ इतना, ये जो yellow color है ना, this yellow colors are called contacts, okay? Since it is connected to the poly, so it is called a poly contact. And blue color is a metal layer, and that brownish color which one you are looking like poly. So poly and this metal has to be connected. So you need a contact. This contact is called a poly contact. This small rectangular size, yellow color. Okay. Similarly, you can find for the active contact also. Okay, Sujit, continue. Huh? To
Okay sir.
talk about the each layer, right? Otherwise, it will be no, they will confuse otherwise.
Oh okay sir. Okay. So now we are going to connect our VDD and ground. So our VDD of layer metal 1. So we are going to connect VDD and ground for the each metal 1 layer here. So also our substrate is not here because in circuit we have used the body. So body is not available here. So we have to invoke the body of this too. So first click on this and go to the property, and in the parameter you have to choose body type. So the PMOS. So either you are know, selecting integrated or detached. So I want integrated body here, and where you want to left tab or right tab. So we want here because here a drain is already there. So we want body on the left side. So we have choose this. So this is the body, and the body and source are connected as per our schematic. You can see in this body and source is already connected. So we have integrated our body to the source. Now these two are going to connect to the BDD. So we are going to create one metal layer here and attach these two. Okay. So okay. So we have attached our body to our source of PMOS, and after that we have connected these two to our VDD, and this is the VDD pin, and we have provided a top rail of metal of VDD here. So similarly we are going to apply for the ground, means NMOS also. So just go to the property of here PMOS, so select Q and the parameter body type integrated, left side or right side. So right side we have also all chosen not drain, so we want left side. So left, click and OK. So it is attached to the source here directly. Now we are going to create one connection from metal. So okay, So now our input is connected to the input of this two PMOS and NMOS as per our schematic. Uh, PMOS and NMOS gate is connected and input is directly connected to this connection. So PMOS gate and NMOS gate is connected and our input port this is connected to this. So one connection has been done. Output is connected to drain of PMOS and drain of NMOS. So drain of PMOS and drain of NMOS is directly connected and output is connected to this connection. So our output is connected to these two connections. Now uh, this body of NMOS is connected to source of NMOS and these two connection is connected to the ground. So here body source and body of NMOS is connected together and these two connected to the ground pin directly. And the last connection is uh, body of PMOS is connected to source of PMOS and these two connected directly to VDD. So body of PMOS is connected to source of PMOS and these two directly connected to our VDD. So our all the connection has been correct from our side. Now we are going to design rule check for this layout of inverter. So these are four pins: in pin, VDD pin, ground pin and out pin. So our layout is complete. Now we are going to check the design rules for this layout of inverter. For that we are going to check uh, as a Sura, and here we are going to run DRC, in which our library is defined demo, cell view directly, type of view as layout. So we are going to click on OK. So the DRC has been done and we are getting three errors. Okay. So first error is oxide spacing. This two error is oxide to poly spacing must be less than 0.2 micrometer. So we are going to check this here. So this is the violation. So the rule is um, 0.2. Okay, let's check how much it is. Okay, it is less than 2. So we have to reduce this. So for that, so it is now not so we have to reopen this design once again. So we have to align the these two layers first. So this is a realign. So we can snap by choosing S, by pressing S on the keyboard. Also we have to realign these two. So we have to press S. Up to this maximum this. Okay. Now we have to So these two are realigned. Yes. So now we are going to check again the DRC errors. So go to the Asura, run DRC. So one error, metal width must be either equals to 0.3 micrometer or it should be greater than 3. So we have to check where it is coming. This is this. So we have to check either it is 0.3 or not. It is less than 0.3. So we have to enlarge this. I guess it is going to be 0.3 now. So we have check and save. Now we are going to run DRC again. So we are getting only one error. This NIM2 enclosure must be greater than 0.1 micrometer. So where this error is this. So we check. Okay. So it is less. Okay. So we have to create NIM. So the DRC is NIMP. So we have to enlarge the NIMP. So here is NIMP. No. So no DRC found. So the enclosure is less. So we have increased the enclosure of this active area. So we are going to test it again. So override the rule file. So there is no DRC violation we found here. So we have completed our layout with all the correct rules. So after that, after the completion of this DRC, we are going to check whether our connection is correct or not. So we are going to compare this design with our schematic. For that we have to going to use the LBS layout versus schematic check. So we are going to choose here Asura. So now run LBS layout versus schematic. So first we are going to choose the library of the schematic. So library is demo, cell view is inverter underscore demo, and our view type is schematic. And for the layout, library and cell is same, but our view is changed. So we are going to compare these two for the connection. So for that we are going to click on OK. So total DRC violation is 0 and our all the cells are matched. So this is the LBS clean design. There is no layout versus schematic error. So schematic and layout perfectly match. So if we have chosen wrong naming here, so it will give you the error mismatch of the instance. Just see if we change this name out1. Okay, now if you are going to compare these two, okay, so it is a text, so it is not taking, but it would be a LBS error. So by default we are going to text it, so it will not take any error. So LBS is clean. After that we are going to parasitic extraction of this LBS and DRC clean layout. So for that we are going to extract this layout for parasitics. So go to the QRC, and after that you are going to run Asura here. Now first setup. So technology is GPDK 180 already selected. Extracted view, extraction, RC, filtering. So parasitic capacitor include as a comment, and parasitic resistor is also you have choose include as a comment. Run details you can leave as it is. Click on OK. So so the QRC is succeeded, and a view is generated which is AB extracted in our library demo and cell name as inverter underscore demo. So parasitics extraction is completed till now. So let's see where our parasitics is looks like. So first go to the, and in this library window we have created one schematic, one symbol, one layout, and after that AV extractor is also created. So choose this view. So this is the parasitics. So let's see. So these are the parasitics which is between the connections R and C of your design. So these are the parasitics. So this is the resistance. So if there is any joint, there should be a resistance. So this is the resistance and capacitance. So these are the known as the parasitics of your design. At any joint and any different type of layer, the parasitics exist. So this is the parasitic extraction of our layout is done. After that, we are going to simulate this parasitics, means include this parasitic in our schematic, and after that we are going to simulate this. So for that you have to create one cell view again. So till now, any doubts? Okay. So now I'm going to close this window and I'm going to create one cell for testing this parasitic. So in demo, this is the library. Okay, file, new. Inside the demo, I'm going to create one cell view and name as inverter underscore demo underscore post layout simulation post, and we are going to create one symbol or schematic. So schematic, okay. So this is the schematic window in which we are going to invoke our symbol of inverter. So press I and we are going to choose the symbol where we have created in the library demo, and this in this recently we created in this there is no view available. So in the demo site we are going to choose our symbol of inverter here. So okay, so we have chosen our inverter window. In this VDD is here, ground is here, out is here, in is here. So we are going to attach it to all the 4 ports. So we are going to choose ports. So first input output port as a VDD and ground. So we have VDD port and ground port, as well as we require input and output port. So first input port, name as in, you can name in which you want. So in is here. Similarly, you require an output port, so you can name according to you out. After that, we have to connect the ports through this symbol. So press either W or from here and connect these ports through wires. Okay, now check and save. So our test bench is ready, in which our schematic layout and AV extractor view is invoked. We are going to invoke in the AV extractor view in this schematic. So for that we are going to create one config cell here. So go to the this window. Now go to the new. Go to the cell view creation. In the cell view creation, we are going to choose the configuration view type. So here you are going to choose the config, name as it is config, okay, and then go to select okay. So now configuration is here. So top cell is demo under the post layout simulation, and view type you have to use a template. So here in the template section you are going to use a spectre, as our simulator is spectre. So choose the spectre here and click on to the OK. So these are the global bindings here, and you have to choose view type from my view to schematic and click on OK. So these are the hierarchical comes under you. So in the demo there are 2 schematic. We are going to use the post, but in post we are invoking the demo inverter demo of, so we have to change this schematic to the AV extracted. So in the view type, either you have to write the AV extracted, so AV underscore extracted. So we are going to change the view type from AV extracted. Also you can see here bound cell demo inverter and demo to view as AV extracted. So in the demo site in this post layout simulation, you can also see, check whether this symbol is connected to your schematic or your AV. So descent, in the descent read you can check. So right now it is connected to schematic. So first we have to apply this. So AV extracted is chosen. So now close this window and save this. So it is saved. Okay. Now check and save here this. Choose to AV extracted. So this is the AV extracted view is generated. So close these two windows. Now we are going to simulate the test bed which we have created here, demo config. So I'm going to open the config. So either you want to open the config or no. So if you are going to open the configuration, we do not want this, as we already did the configuration, the post layout configuration. So we just want to see the demo post schematic. We don't want to configuration again. So this is the configuration window is open. Also we are going to check. So it is in AV extracted view. So now we are going to simulate this. So here we are going to launch the simulation window ADEL. In this, similarly you have to give the values of all the ports. So for that, go to the setup, go to the stimuli and select. So we have given ground here, DC 0, apply VDD DC 1.8, input. You can give any value or as similar from the schematic. So pulse, so voltage 1 is 1.8, period is suppose 100 and pulse width is 50, rise time is 0.00001 and control time is 0.00001 and apply here. Now we are going to choose the waveform on which port we are going to give waveform. So input and output. So in and out are selected. Now we have to choose the simulation type. So just go to this transient analysis and we are going to simulate this for 1 microsecond. Okay. Now simulate this. So our simulation has been done and just see our spike is reduced from 2.4 to 2.2. So this is the post layout simulation of our. So as per our requirement, if we are going to design, if we design our layout efficiently, then our result would be better than our pre-layout simulation. So this is the post-layout simulation. So that's all from my side. Till now we have seen
ये
the schema. Yes, sir.
सुजीत, जस्ट
Yes, sir.
एक्सपोर्ट जीटेस्ट कैसे करना है बता देना. जस्ट एक्सपोर्ट डीजेस टू आउटपुट में जाके.
Sir, GDS to okay.
हाँ ठीक है, वो निकल जाएगा. जस्ट सेव एज करना है जीटेस को.
Okay, 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 sir. Okay, 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 sir. Okay. So for the GDS, so GDS for the here you have to go to the file here, and here choose export, and you have to choose the stream file here, and you have to choose the stream files. So here we have created one library demo, right? So demo, in the demo, inverter demo layout. Okay.
दूसरा नाम से दे देना. दूसरा गिव डिफरेंट नेम.
So first we are going to mean, sir, we have to create the GDS, right, sir?
हाँ हाँ हाँ. एक्सपोर्ट करना है ना, इंपोर्ट क्यों?
Import.
तुम लेआउट तो लाओ पहले. लेआउट तो विंडो खोलो. लेआउट विंडो को जाओ.
Okay, sir.
Now you export na here.
So we have to choose the technology library. So we have chosen GPDK 180 nanometer technology here. And in which library we want to export our GDS? So in the library demo and top levels here, and view type is layout.
Geometry.
Session completed. So we have inverter underscore demo.gds file created in our demo library. So we can see
.gds inverter underscore demo .gds.
So we can see from here.
No, you can close it, and that again you close the window and call that.
Yes, sir. Yes, sir. Yes, sir. Yes,
report
sir.
so that you can.
So shall I show, sir?
हाँ.
Okay, okay. So first we need to exit from this window.
पूरा बंद कर दो. फिर जहाँ पे
Close all data.
exit करो. Close मत करो. पूरा exit
Okay.
करो.
Now we are going to exit this. Okay.
Don't do any force close. Okay. Don't do
Yes,
that
sir. Yes,
any
sir.
force close. No, I'm asking the students and telling the student never you do the close cross button. Okay, it will unnecessarily take a log data. So your memory will get filled up. Tool may
We are
not
going
work.
to check.
So
it is
when you
exit.
will exit, properly you exit it.
So now we are going to list the file available here, ls. So in our
Go to the again Bharti show.
cadence library.
Or
CD.
Bhakti's layout, no. Already done,
Yes,
na?
sir. Yes, sir. Yes, sir. Yes, sir. CD cadence in folder. I am going to. Also, we are going to check here. So we are going to demo. So we have to change to the demo. And here also ls. So in the demo, CD. In the layout. Let me check, sir. The GDS in the
GDS
cadence
library.
library. In the cadence library, I guess GDS is available. This.
Where you saved that one? No, in top of that one, and just check it.
This is the GDS.
Ha ha
In the
ha
top, in the working library.
ha ha
In
ha.
the CD cadence.
Oh, where
So
it
we have
is?
named it in
Ah,
the
this one. Na,
CD.
you
Yes, sir.
just open this one, na. I think here only, right?
Yes, sir. Yes, sir.
Ah. Now open in this one.
Inverter. Yes, sir.
You open this file, na.
Okay,
You
sir.
go to the beer layout window and import this one.
Import this.
You have to go. You have to again open the Bhakti layout window. It will not open like this, right?
No,
Don't
no, sir. It will not. So
no
it
no
is only the geometrical data. We cannot open as a layout.
no.
So
You
we
can
have.
open when you go to the layout. Okay.
Yes, sir.
You go to the layer window. The way you did the export, na.
Yes, sir. So we have to provide the layer map file for this.
Have you have given a layer map file?
This is the generic, sir. This is the generic.
No. It just try to open it. Just to
Okay, 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 sir. File. So we can export or import this stream and choose here stream file. Uh, inverter demo.
चला गया चला गया ऊपर हाँ
This open and in the library
हाँ
top cell view like inverter. Attach the technology file and so option.
snap to grid देना पड़ेगा ना ऑप्शन.
Sir, but it will override the previous inverter demo file. Because and if we are going to change this name, then it will give you the error. If we are
Why?
going to create the name of top cell should be same as we have created the GTS in under the name of inverter underscore demo. So the top cell view should be same, but the
But you can
similar.
open in the different folder, right?
Yes, sir. Yes, sir.
If you in the same things, then it will override. But
So it is a cell view. So we have to choose the different library. So let me. So in the layout Sujit. Okay, sir. Translate. So it has been created. So in the layout Sujit, so we are going to open the layout Sujit. So we have created here input demo. So click to OK. So it is here. So we have converted from GTS to layout once again. In the same video, it will override the previous layout. That's why we have chosen.
other
So once
folder.
again, other folder, sir. But
Okay,
the
I think
limitation. Yes, sir.
this is okay now. Okay.
Okay, sir.
So so anybody has any doubt? Okay, so I think अरे बाबा तुम लोग क्यों नहीं आकांक्षा?
Yes.
See, take this video and start practice from beginning to the end. What I taught in the class and all issues, everything's that is demonstrated now. This is tool practice. You have to do it. Okay, and
Yes.
first of all, what he started, I think it is already recorded. And go once again the steps and follow. Again, you have to do through the VPN. Okay, and if you will face the problem, then just write to me, and we will see how you can sort it out. But yes, these steps you have to understand. Even if you cannot do the practice, but these things you have to understand and put the questions. Then let's will have a discussion on it part. And if you can do through the VPN, then well and good.
Sir, we don't know which software we are using here. Like, can you please send any link or something from where we can download the software?
Arey Baba, it is the you cannot need to download. You cannot download. It is already there in the lab. You cannot download in your system. The software is not available. This is very costly software. It is a crores of rupees. This cost, but academic price is bit less, but not in the lakhs. So you cannot download it. You can download it. It needs, but license you will not get it. So you have to do through the our server only.
So, sir, like the students who are not in college, they have to just understand the steps only.
No, they can get connected through the VPN to the server. The server.
Okay, okay, sir.
Okay. So you have to get connected through the VPN. That's why I told na. If you people are acquainted with VPN, you can get access to the server and the licenses. Okay, you can start working. So you cannot download in your system, and even if you are there, you can do access to the lab server, and you can do working.
Sir, which password and username we have to use?
Username and password we have to create it per individual. So that Sujit will do. Sujit or Sasi, they will do that, and they will give you the username password. And your username will be your roll number, and your password will be your roll number. Keep in mind, okay? And I don't know how I will get your roll numbers. I think somebody has shared with me, na? Narendra. Narendra, are you there?
Sir, how many students will be created user?
77.
Lot of students there, sir.
Yes, yes, yes.
Yes.
Narendra?
Hello, sir. Yes,
Where
sir.
are
Hello, sir.
you?
Yes, sir.
Whenever I am asking, you are not responding. You are the class monitor,
Your
right?
voice network error was there, sir. I was there, sir. Yes, sir. Yes, sir. Yes, sir.
So you have sent me the roll numbers, right? Mail, right?
Yes, sir.
Okay.
Yes, sir.
So
Sir, the
what is your
limited license is there, sir.
huh?
Limited license is there, na? How many
Yeah.
users will use?
Oh, many licenses are there. Don't worry.
Replies are there, sir, in the comment section, sir. In the chat section.
What you are talking?
Nothing, sir. Nothing, sir. Nothing, sir. Nothing, sir. I will tell it, sir. I will tell you, sir.
Okay, Madhu Jain asked, sir, what would be the evaluation process and deadline of submission of this lab course? Madhu Jain, let's really start first, then we will go for the evaluation. Okay, Madhur.
Group में भी तो दे सकते हैं।
Madhur.
Group में भी दे
Yes,
सकते
sir.
Madhur, don't worry for the evaluation. First, you do something. If you can do something, I will be happy.
Yes, sir.
Okay, if you are able to process the only the inverter part from the what Sujit has done today, if you can do on your hand, that is more than enough. And maybe if you do it, then I will go to the next assignment I will give you. At least inverter flow, you try to get it. And regarding the evaluation, I will decide how will we evaluate for the lab. Lab will be the very practical approach. What is the steps I have told, what the tool we are using, these are very, very fundamental and experimental with the, some because it is online. So otherwise it would have been, offline, then tool flow, everything's that would have done. Because it is not only full custom, we will do the semi-custom. Once I will start the theory course, so some Verilog and all these things, and also semi-custom flow, then we will go to the FPGA flow. So there are three basically in the VLSI lab. We do the full custom design, semi-custom design, and FPGA flow. But I'm not sure how much you can do it by offline. But we will try to do as maximum as possible. Okay, and based on that, you will get evaluated at the end of the semester.
Sir, what will be the duration?
Jaina, Silas, Jagat. Sir, total how many experience will have? Actually, generally we do 8 to 10 in the offline minimum 8 to 10. But I don't know how much you can do. I cannot assure now because you are offline. When I'm asking the theory, even when I am getting interacting with you, nobody is responding to me. So I mean around 45 people are attending, 45, 50, around 10, 15 people are remaining absent in the class. So I'm not able to track the way I track in the offline. So this is obviously this is a pandemic situation. Maybe if people are facing the problems in the other side, I cannot say. So depending upon your work, and we will try to do some experiments on the full custom and semi-custom. FPGA not possible because you don't have a But yes, but hardware part we cannot do, but the software part we can do. Okay, any questions, Jaina? Jaina, I think you got clear, right? Mayank, what will be the deadline for the each experiment? Deadline is, if you want, I will give, but again, I don't know now what is the constraint from your side. Okay, so as I am completing, I will see that how fast you are giving and completing, how fast you are submitting me the assignments. So there is no time constraints for that. But who will be the active and that will be noted down and for the final evaluations. Aman, sir, please share the lab manual if available. This is the lab manual. Which is the video Sujit has given. This is your lab manual. There is no standard lab manual like you have in the first year and second year for the specific experiments. These are all open experiments. So there is no specific manual, but yes, flow, it is already, this is the flow we have to follow for each circuit. I think it is clear for the Aman. Hrithik, so by which day the access to the cadence will be available to us? As per your, we will create it. Maybe Shashi? Shashi? Shashi?
Yes, sir.
Sure, I think you can create today, right?
User ID and password, sir.
Yes.
Okay.
So
Okay.
today you create it, and by tomorrow I think you can get access. Hrithik?
Okay, sir.
Okay. Okay. So any doubt? Any other doubts? And if you, sir, when would be the deadline for submission? Madhur Jain. कब रे बाबा 3 मधु जैन मैंने पर शुरू नहीं हुआ है. He is asking when would be the deadline for submission. Madhur, can you submit by tomorrow? Madhur.
No, sir. No, sir.
Okay, when you can present, when you can submit.
So I can't tell now. I have to try first using that.
That's right time, na. So you try
Yes.
fast. You try fast. Don't worry, huh?
Yes, sir.
You try fast. If you can do by offline at least one flow for the inverter, that is more than enough to learn the full custom. Okay. Only other circuit will give you the practice. So I will suggest to all of you to at least you practice the inverter circuit from the circuit simulation to the GDS2 and export the GDS2 and import GDS2 once again. If you do it, then more than enough. I will be happy if you have completed this batch at least within a 2 to 3 days or 1 week time. I will see the how fast you are doing. No, this is not like a particular time period. So in the offline, anytime as you know, if you learn, that will be a value addition to you. If you don't learn, that you will not get anything. So that's all. Okay. If you practice, then that will give you to the value addition to your profile. Evaluation and these things you will see how you people are doing accordingly. I will decide how to evaluate it. Obviously, there will be evaluation and some grading will be there for this lab. I will decide after a couple of weeks what to do. You ask same questions after some time, not now. I see that how much you can do it. And I will closely monitor and who has done it, let they submit either personally to my WhatsApp group, or you have any doubts, then anything also you can put in the WhatsApp group, and I will try my best, and I will ask the Sujit and Shashi to solve it is related to any creation of your ID or some tool flow or kind of stuff, or any technical doubts. I will clear your doubts. Okay, that's all we can help you from our side. But all the all depends upon you how you can access the tool, how you can get the info to learn these tools, tool flow. Okay, Madhur.
Yes, sir.
Okay. So once inverter is done, then maybe you will go to the basic gates, NAND and NOR kind of stuff. Let's complete. No, by this, can you by Friday can you complete this stops? This experiment? Okay,
Yes, sir.
deadline is a Friday.
Yes, sir.
Okay, and sometimes
So
I will
can we
be.
do?
Huh?
So can we extend it till Monday, like 1 week?
Who is asking?
So Mayank.
Why Monday?
Sir,
So because
actually, we have a gate exam on 5 and 6 for electrical.
Okay. Okay, Monday.
Sir, like we have exam on
Next Monday, randomly I will ask the student in the class, and he has to demonstrate the tool flow. No, okay. Akanksha.
okay, sir.
Yes, sir.
Randomly I will pick the number, my name, and who will be picked up, and he has to demonstrate the flow. Okay, next Monday, 3 o'clock. Akanksha.
Yes, sir. It's okay to me.
Okay, Mayank. थोड़ा मैसेज भेजो किसी का नहीं होगा तो भी फिर हो पाएगा. Hey, so 1 week is more than enough. We generally give 3 hours to complete this job in the lab, in offline. Okay, you try, and Monday we will go for the demonstration of this one. Huh?
Okay, sir.
Okay. चलो मीटिंग एंड करते हैं. 5 बज गया. So if you have any other doubts, then let me tell. And तुम्हारा स्ट्रेंथ क्या है, कितना मयंक? तुम्हारा क्लास का 77 ना?
Sir,
So
76.
76 actually.
76.
Yes, sir.
9 students absent till today. Today also. How can I know those people? Okay, I will take the attendance again once again, so I can get it then. Okay, then shall we leave now? तुम लोग का डाउट है नहीं तो बंद कर देते हैं. ऐसे खड़ा बैठे के क्या फायदा फिर?
Yes, sir.
Okay.
Yes, sir.
क्लास है क्या अभी तुम लोग का?
No, sir. We don't have a class.
Okay, enjoy. So if you don't get any access, no, just put in the group so that Shashi will solve the issues. Chalo.